So this is the next question we have. It says consider the reaction A gas plus B gas gives you C gas. Equilibrium constant Kp is equals to 1. If reaction quotient at time t is 10, then delta G is 0 at time t, but delta G naught is never 0 in this reaction. Delta G at time t is negative for forward reaction. Delta G at time t is 0 and reaction moves in forward direction. Delta G at time t is positive for forward reaction. Let us solve this question. Delta G naught is equals to minus 2.303 RT log base 10 Kp. As Kp is equals to 1, so delta G naught क्या होगा? 0. Delta G is equals to delta G naught plus 2.303 RT log Qp, which is the reaction quotient, which will give us the result. This is equals to 2.303 RT. Now let us go through the options. So यहाँ पर हम देख सकते हैं delta G naught 0 है and delta G जो है वो positive है. So the correct answer is option 4, that delta G at T is positive for forward reaction. Now let's move to the next question. This is the next question we have. It says 1 mole of monoatomic ideal gas expands reversibly and isothermally from Vi to V final at temperature T. If initial and final pressures are Pi and P final, select the correct statement. Delta G equal to 0, delta G equal to minus RT ln Vi by Vf, delta G is equals to RT ln Pi by Pf, delta G equal to RT ln Pf by Pi. Let's solve this question. Students, as we know, delta G for isothermal reversible process is minus nRT ln V final by V initial, or we can also write minus nRT ln P initial by P final. या फिर for 1 mole of the gas we can write RT ln P final by P initial. So this expression is given in option 4, hence the correct answer for this question will be option 4. Now let's move to the next question. This is the next question we have. It says consider the thermodynamic data at 25 degrees Celsius. The enthalpy of formation of carbon dioxide is given X, for water it is given Y, for methane it is given Z. The heat of combustion of methane in kilojoule per mole is. Let's solve this question. First of all, let's write the reaction. CH4 gas plus 2 moles of O2 gas. This gives you CO2 gas plus 2 moles of H2O liquid. Now, the enthalpy of this reaction, or standard enthalpy of combustion of carbon methane, is equals to standard enthalpy of formation of carbon dioxide plus 2 times of standard enthalpy of formation of water minus standard enthalpy of formation of methane. For oxygen, the standard enthalpy of formation is taken as 0 because it is present in its standard state. So, formation of carbon dioxide is given X, formation of water is given Y, and formation of methane is given Z. So, enthalpy of combustion of methane is X plus 2Y minus Z. So the correct answer for this question is option 3. Now let's move to the next question. So this is the next question we have, which says consider the graph for 1 mole of monoatomic ideal gas and select the correct option. This is the graph given. Here it's mentioned delta H A to B is equal to 0, delta H C to A is less than 0, delta H A to B is less than 0, delta H C to A is 0. Students, if I talk about A to B, here we can see its compression, pressure as well as volume is decreasing. So we can definitely say that temperature is decreasing and delta T is negative. So enthalpy change must be negative. Hence, delta HAB should be less than 0, which is given in option 3. So the correct answer for this question is option 3. Now let's move to the next question. This is the next question we have. It says consider the following detail for water. Kw 10 to the power minus 14 at 25 degrees Celsius. The pH is mentioned X. Kw is 10 to the power minus 12 at temperature 90 degrees Celsius and pH is given Y. Select the correct statement. The statement 1 says X is greater than Y. Second statement says at 90 degrees Celsius water is acidic, while at 25 degrees Celsius it is neutral. Third statement says at 90 degrees Celsius water is neutral, while at 25 degrees Celsius it is basic. Fourth statement is Y is greater than X. Students, यहाँ पर हम देख सकते हैं कि H ion concentration you will write 10 to the power minus 7. So pH or value of X will be equal to 7. Here the HIN concentration will be 10 to the power minus 6, which is square root of this. So Y will be 6. So at high temperature, the pH value will be lesser, but that doesn't mean it will be acidic. At higher temperature, degree of dissociation of water increases, because of which pH of water decreases and the solution remains neutral. So it is clear from the expression that X is greater than Y, and the correct answer for this question is option 1.